Hello everybody, thank you for checking out my video on Unit 3, Day 2. It's currently we've done synthetic division, and today we'll do a couple different things with synthetic division, being able to find missing internal values and being able to get straight to the remainder via the remainder theorem. So with that being said, let's start with the remainder theorem. So you can use the remainder theorem and just plug in the opposite of your divisor to find the remainder. Sometimes the question is just going to be, what is the remainder? So in this same problem, we could have set it up and worked it out as I've done here already. That's a long synthetic problem. It's 3 zeros in this one. At the end, the remainder is 3. But as I'm telling you, the remainder theorem, it allows you to go directly to finding the remainder. So anyways, enough talking about it. So all we're going to do is we're going to replace x with the opposite of our divisor. Just like that same number we put outside in the box in synthetic division, we're going to replace x with the opposite of our divisor, which will just be 1. Whatever I get from simplifying this, that's the remainder. 1 to the 5th power is still 1. And then 1 times 6 is 6. 1 to the 3rd power, make sure before you multiply, you're doing exponents because exponent comes before multiply. 1 to the 3rd power is 1, and times -4 is -4, and then finally there's a plus 1. 6 minus 4 is 2, and 2 plus 1 is 3. So just like we showed you a moment ago on that screen, the remainder is D3. So by all means, you can do it either way. It's just, again, an alternate way to get to the remainder a lot faster. Just to do another one or two, because you'll have some on Delta that you'll definitely use for practice. What's the remainder when x to the 3rd minus 9 is divided by x plus 2? If I was going to do synthetic, it would be a 1 for this. There's no x to the 2nd, no x to the 1st, a 9, -2 in the box. Whatever I get right there, that's the remainder. But again, what we're learning today, all you have to do is plug in the opposite. So I'll plug in -2. -2 to the 3rd power is -8. And -8 minus 9 is -17. So that's the remainder. Here, what would you plug in on this one? Well, hopefully you said you'd plug in +1 for your x's. 1 squared is 1, times 7 is 7, 3 times 1 is 3, and plus 2 gives me a final answer of 12 for the remainder on this one. So that's the remainder theorem. Don't forget about it. You can kind of think of it as almost a cheat method when you don't want to do synthetic. Now, be aware, like ultimately on a quiz soon and ultimately a test, sometimes it's going to tell you divide the whole thing out like we did with synthetic division on the first lesson. Sometimes it's just going to say, find the remainder. So the second part of today, we're going to use synthetic division in a setup. We can actually use remainder theorem either or both ways to find a missing value on the inside, which I'm going to refer to as k. I'm going to use a couple examples from a previous lesson. Again, I'm definitely trying to do examples as much as I can that weren't used in class. So treat everything normally. I know I'm going to have -2 outside of my box. I got a 1x to the 3rd, a 7, a k, and a 3. And since I've taken k away, this is what's different here. I'm finding a missing internal number. In math class, you can't just take information in and not be replaced. We're actually replacing with the fact that we know the remainder is -5. So I'm going to put it in the remainder spot. Now from here, I'm just going to work from both sides and try to work my way back to k. So let's see what happens. Still drop the 1. 1 times -2 is -2. 7 minus 2 is 5. 5 times -2 is -10. But I can't subtract k and 10. So on this side, I'm stuck. But again, I have this -5 as a remainder, and I'm going to use it. 3 and something makes -5. If you can't tell, 3 and something equals -5. It's a lot easier when you write it in the equation form. Now I can get rid of the 3 by subtracting, and the reason we couldn't see it, it was a negative number. the -8 in that spot was a little bit tougher to decipher. But anyways, again, we're looking for k. Now remember, these numbers all multiplied. Whatever number was here would have times -2 and made that spot right there. So isn't it 4 times -2? That would make -8. Now that I've got that far, I can finally tell what my missing number is. All by focusing on this spot. Something minus 10 is equal to 4. That one's kind of easy to do without the equation. But anyways, you get rid of minus 10 with plus 10. And k is 14. Check out another one. In this one, k is negative, and it's in a different spot, which just means I'm going to work backwards a little bit longer than I just did. So I definitely like this example. So hopefully you know what goes in the box. Hopefully you said 5. Hopefully you know your coefficients on the inside. 1, negative k. See, k is the representing the coefficient. It's like, just like it's in front of the x, just like the 20 is, or the 1 was, and the 26 is. Leave a little gap. And don't forget the remainder. This time is 1. Top the 1, boom, 1 times 5 is 5, and I'm stuck. Can't do negative k plus 5. Go to the other side. 26 and something will make 1. That was not too bad, negative 25. 26 and something makes 1. Just subtract 26 to get rid of the 26. So negative 25 again. And remember, this number would have multiplied 5 and made negative 25. It would have had to be negative 5 times 5 to make negative 25. Now we can fill this number in. 20 and something is negative 5. 20 and something is negative 5. Subtract 20. That had to be negative 25 in that spot. And that's a good number to have because I need to be able to make a number that will come out of a 5 times something. What times 5 would make negative 25? Negative 5 times 5 would make negative 25. And again, now that I got all that, I can ask myself, negative k plus something is equal to negative 5. Get rid of positive 5 by subtracting 5 to make negative 10. And I still got a negative on my k, which is a negative 1. I divide both sides by negative 1, and I got a final answer of k equals 10. Pretty good so far. I'm going to do one more finding k question, really just because I want to show how you can find, or you can use the remainder theorem to do these. You don't necessarily have to do the setup like I'm setting it up. There we go. So anyways, good setup here. Put in 5, the opposite. We got a 2. We got a negative k again, so I guess I was doing a negative k anyways. Maybe you can pause it at this point, work ahead of me. Oh, and by the way, perfect factor. Think about it. I didn't tell you the remainder, but if it's a perfect factor, that means it divided evenly, it divided cleanly. So the remainder, in this case, is 0. Drop the 2. 2 times 5, 10. And again, I'm stuck. Let's work backwards. 5 and what makes 0? Negative 5. What times 5 would make negative 5? That'd have to be a negative 1. Negative 6 plus something is equal to negative 1. All I got to do is add 6 to get rid of that. X is 5. What times 5 will give you that 5? Just 1 times 5 will give you 5. And then finally, I'm here. I got 2 numbers that will help me find k. Negative k plus 10 equals 1. Subtract 10. Wait, this can't be the same problem. Divide off the negative 1 and k equals 9. Might have been the same problem. So, oh yeah, with doing all that, you can use the remainder theorem, as I was trying to say. You know you got to plug in the opposite So we're plugging in 5, which is the same as the opposite we used here. Now I know that when I plug it in, I just got my same equation, replace x with 5. I know that the remainder again was 0 because it was a perfect factor. So this better equal 0, or it's got a variable and I'm going to have to solve for. 5 to the third power, 5 times 5 times 5 is 125 times 2 is 250 minus 25k. 5 squared is 25, and then 25 times -1. Negative 30 from this, and 5 and 0. Cleaning this up a little bit, let's change colors so this looks a little better because I'm getting crowded in my space. I can put all these constants together. 250 minus 30 plus 5 is 225. So right now I'm sitting at negative 25k plus 225 from adding all those together still equals 0. I'm going to subtract 225 from the other side. And finally I'm going to divide off this negative 25. And it looks like it's going to divide nice and pretty. And it looks like k equals 9 when you divide it, which is the same thing we had earlier. So again, it works with the synthetic setup or the remainder theorem setup. Math always verifies itself. Hope this video helped out. Definitely a topic that'll take a little bit of time to get used to. Unit 3B is the delta. Let me know if you need any help. Work it out neatly. If you miss it, bring me your paper, show me what you missed, and it's generally pretty easy for me to find a mistake.